All right, so good morning, Sebastian, and good afternoon to the rest of you. We continue with our experimental psychology workshop with OpenSesame for the second day today. We have Sebastian Mathot here again to guide us through, and today we're going to continue with our practice, and especially to see how we can implement not only an experiment, but also how to integrate it with eye trackers, right?
No, actually, that's day 3. So today we're going to take a look at how we can run an
online experiment.
Online.
Yeah, the online experiment, I'm sorry. So today we're going to focus more on the online experiment. Some of you are sitting here with me in one of the lecture rooms, lecture halls at Kijang. So, and I would just like to inform the rest of you who would like to join us on site tomorrow for the third day. It is also possible, but we'll use a smaller room tomorrow. But that's an option for some of you who wants to go to the Kijang campus tomorrow. If you want to join us on site, it's possible. You can find us at the main what's called that? How do we call the staff on the main staff room? All right, then I'll give the screen to Sebastian. Thank you.
All right. Thanks for the introduction, and welcome. I'm happy to see all of you again, and also cool that you're sort of semi together in at campus. I think I wish I could be there. Actually, I think workshops are much nicer if you're all sort of together working on it. But we'll have to make do of this hybrid session, as they say. So today, what we're going to do is we just like the first day we have a sort of 1 day part for our workshop from 1 until 5 p.m. your time. And we're going to start with this presentation, and I'll give you this presentation will be really short. And I will give you a general introduction to online experiments and what it basically means conceptually to run an experiment online. And then we're going to work on a tutorial that I know some of you have also been creating tutorial material for in Indonesian. The cats, dogs, and capybara tutorial. What's nice about this tutorial, I think it's a fun experiment, but also, wait, now I'm getting a little bit confused about which tutorial did we do the first day again? Just the basic beginner tutorial, right?
The eye gazing tutorial.
Yeah, of course. Yeah, so I just thought, oh, because sometimes I start with this tutorial. So what I think is nice about this tutorial is that it's relatively compact, and then so there is a relatively short section of general tutorial, and then it is followed by a series of extra assignments to sort of improve your experiment. And these extra assignments have different difficulty levels that you can choose to fine-tune your development skills, so to say. So if you're still kind of at the beginner level, you can choose something easy. If you want to do something with a little bit of Python or JavaScript coding, you can choose an assignment along those lines. And the nice thing is also that even the very basic experiment, without doing any of the extra assignments, lends itself to being run in a browser or as an online experiment. So that's what we will focus on. Then we'll take a short break, and after the break, we will move from basically developing the experiment on your own computer to uploading it to a server called mindprobe.eu. I will create accounts for you on Mindprobe and give you login details for that. And Mindprobe is a it is a server that runs software called JTOS. And how does that work? Well, you will see it, of course, later. But basically, you have to think of it as kind of a server that you upload your experiment to, and then it will generate links, and you can give those links to participants. And then to participate in the experiment, participants simply click on the link. It starts the experiment in their browser, and the data is sort of stored on the JTOS server, so on mindprobe.eu. And later you can download actually the data from mindprobe.eu, and that's what we will touch upon also on the last day, the 4th day, when we will start working with data. And I know actually that Wisnu has plans setting up a Mindprobe-like server at Binus University. Is that server by any chance called Pikiran Probe?
No, But
No?
I just got news today that we got the budget and the IT infrastructure people are working on it. So in sometimes very near in the future, we will have our own data server at Dennis. But now for the workshop, we will use Minecraft.
Okay, all right. Then we but everything that you will learn that will work on Mindprobe will then also work on your own server located at Venus University, because it will run the same software. And I saw that there were a few. I saw on my website analytics that there were a few referrals from a website called Pikiran Probe. And Pikiran, if I'm not mistaken, means essentially mind, right, in Indonesian. So I thought maybe that's what Wisnu was setting up. But that
Oh
info.
yeah, Pikiran, yeah. I don't know who that is, but I thought I'm the only one working on this kind of things. Like, but
it sounds like you have
that's also
competition, you need to step up your game. Because,
yeah, I need to step up my game indeed. Oh, talking about stepping up my game, I need to inform to all participants that Sebastian and I have been talking about spicing up the workshop a bit.
Yeah.
So the idea is that, so Farah and I and some other people who are participating in this workshop, we're teaching experimental psychology course, which typically run in the odd semester. So next semester, there is an experimental psychology course. Typically, what we do here, we do there is to run an experiment in which students can try and collect data, analyze, make reports, and so on. So they can learn all the processes involved in developing, analyzing, and writing up an experiment. So typically, Farah or I will make some kind of experiment that students can run. But for this year, what Sebastian and I want to do is to offer you, the participants in this workshop, a little bit of a competition. So I told you at the beginning that in July, there will be a showcase demo session in which all of you who are willing, who are participating in this workshop, will showcase the experiments, the project that you've been working on during the 4-day workshop to the rest of our faculty members. And the best project, so Sebastian and I, we will select the best project based on the novelty of the project, the feasibility, and also the validity. So whether it actually measures what it wants to measure. So those 3 simple indicators, the best project will be run in the experimental psychology course. So you'll have an opportunity to start collecting data with your own project if you want this small competition, so to speak. So I hope that will spice things up a bit. Yeah.
And just as a clarification for my part, so what does it, I understand the procedure, of course, because you already explained it to me a little bit, but what does it, so the experiment that will be selected, will it also serve as an assignment to the students in the programming course, in a sense that they have to then re-implement it? Or is it only that it serves as something that the students participate in?
Yeah, so the students typically, they'll not be involved in the development of the project, but they will use the link, for instance, to collect data and train themselves as an enumerator, so to speak. Yeah.
Okay, all right, cool. Oh, then I misunderstood that part, but now I see it. Yeah.
So just like what we did in the experimental practicum at the group.
Okay, and then what we will do then, after I've explained and given you a Mindprobe account, you will continue working on your own experiment, and we will do sort of me virtually walking around thing, asking you one by one whether you need help, etc., where you are with implementing this experiment, and then we will move forward. And so that's the schedule for today. Now, if you want to run an experiment, then OS Web is an important concept, but it's a little bit abstract. So last week, or it's already 2 weeks ago now, we implemented the basic experiment and we just ran it on the desktop, right? So that means you click on the play button and then on the desktop, you get a little window that pops up, and that's where your experiment lives, basically, as an application. This is the normal OpenSesame way. But if you want to run an experiment in a browser, of course, you need to do it differently. You need to run it in a browser, so you need to run it as a website. Now, OS Web is technically it is a JavaScript implementation of the OpenSesame runtime. What that means, simply speaking, is that it is a website that basically runs your experiment. So it takes your experiment, bundles it with a piece of software written in JavaScript, and JavaScript is the programming language of the web. And together that becomes a web page, and you can just load it in your browser, and then your experiment will run. That's the idea. To actually run this for testing purposes, you can, once you start OpenSesame, you will see here you will see this kind of run button. This is this sort of filled green circle with the play thing in it. If you click on that, that will actually really start your experiment in a browser. You can also start the OS web panel. We will see that in a bit. And then you have some more options, and you can click on test experiment in external browser. That is the same. That is the exact same thing. If you click on this button or on that button. What will happen then is that OpenSesame will create a web page for you, an HTML file, and open that in a browser. That makes it look like it's online, but it's actually not. It is still all happening on your own computer. And that is sometimes a little bit confusing because you're used, of course, to the idea that everything that happens in a browser is online, but actually that is not always the case. And in this situation, it is not. What will happen is basically that it will create a file, an HTML file, and on your computer, and then load that in a browser, and everything will happen within your computer. This also means that you will get some kind of link, but if you give that link to participant will not be able to actually start the experiment because the link is just basically a path to a file that lives on your own computer. And in order to give participants links, you need to use MindProbe or some other JTOL server, as we will see later. But just so that you understand that if you click on this test thing, you can test whether the experiment works in a browser, but it is not online in any meaningful way. When you want to make an experiment that runs online, actually, by the way, if anyone has questions, interrupt me at any time, right? You can post them in the chat. You can raise your voice because there are few enough people that you can just ask the question by unmuting, or you can ask Wisnu if you prefer to ask questions in Indonesian, for example. OS Web is a completely separate piece of software from the normal OpenSesame. And they have to be because the normal OpenSesame is written in Python as a programming language, and OS Web is written in JavaScript. So basically what that means is that it has been completely rewritten in JavaScript. There was a lot of work, mostly done actually, credit where credit is due, by a man called Jaap Bos from the University of Groningen, and then later by Daniel Schrij, and yet later by myself. This also means that some of the things that work on the desktop do not work in OS Web. So it supports only a subset of the functionality. And if you want to design an experiment that runs online, of course you want to sort of avoid the nasty surprise that you don't know that you sort of made a beautiful experiment and then you try to run it in a browser and it turns out that a lot of crucial things just don't work. So you can find online, or you can do a built-in compatibility check. So if you start the experiment, if you start the OS web panel in OpenSesame, we will see that later. There is a compatibility check that will give you warnings if things don't seem to work. This is very useful, but it is a bit incomplete because it relies on a kind of introspection of the software that is not perfect. So there is also a list of supported functionality on the documentation side, and that is, as far as I can tell, comprehensive. But of course, it's still a matter of testing, but then you know, for example, that certain items don't work or certain specific functionalities don't work. An example of that we will see today, actually in the tutorial, is that normally in OpenSesame, if you collect a mouse click, you can say, okay, this mouse click belongs to this sketchpad, and then the mouse click will automatically know on which element in the sketchpad you clicked, because you can give them names. That's very useful, of course. And that doesn't work in OS Web, basically. So those kinds of limitations you should think of. Now, a few words about JavaScript. Not because we need to use JavaScript today. You don't. There is no programming involved in this workshop. Not necessarily, in any case, except for the fourth day when we will do a mini bit of programming for the data analysis part. But other than that, we will do everything with the graphical user interface. But nevertheless, you may want to program in the future, or you may want to do one of the extra assignments that requires programming. So a few words. So JavaScript is the language of the web. What that means specifically is that a web browser interprets one specific language, and that language is JavaScript. So in that sense, if you do something in a browser, you're forced to do it in JavaScript. If you're doing things in a browser in a different language, for example, my own Python tutorial site allows you to do Python code, but run Python code in a browser, then it looks like you're running Python in a browser, and of course, in a way you are. But the only reason that works is because Python itself has been then rewritten in JavaScript. So then there's this kind of layer. And for the purpose of OpenSesame, this means that if you want to run if you want to include code scripting in your experiment, you need to do that with JavaScript. So you cannot use Python script in an OpenSesame experiment if you run it online. This is kind of nice, and actually there are many things you can do with inline JavaScript. It is still a little bit more limited than inline Python script, in part due to the fact that OpenSesame on the desktop is more mature. It's been around for longer than OS Web, and in part also because there are some limitations inherent to the language to the JavaScript language that don't exist so much in Python. So it is a more restrictive language, basically. You don't need JavaScript today, right? So don't worry if you think, oh my God, I don't even know what this is. You don't need it. I'm just pointing it out here. But I'm going to say a few words anyway. So and this is mostly, I'm saying this now, mostly at those people who are actually will have some idea of how to work with Python code in OpenSesame. If you don't know how Python code works in OpenSesame, this will probably not mean much. But for those of you who do, you probably know that in Python, in an OpenSesame experiment, if you want to refer to experimental variables, things like the responses, the variables that you defined in a loop, things like that, then you do that by saying var dot and then the name of that variable, var dot response, for example. And that would mean the same thing as in the user interface, putting response between square brackets, right? So in the user interface, you refer to variables by putting them in square brackets. We've seen that in the tutorial, the first tutorial. And in Python code, you would do that by saying var dot and then the name. Now, in JavaScript, you can do the same thing, but you have to say vars instead of var. And why? Well, because in JavaScript, var is already a reserved keyword, so we couldn't use it in that way. You can also, in JavaScript, programmatically create stimulus displays using the canvas object that really looks like the canvas object in Python, but there are slight syntactic differences, but it's conceptually very similar. And that is really useful if you want to create very complex stimulus displays. For example, say that you want to generate a visual search task where you have many stimuli that are presented at random locations on the screen. Think, for those of you who know that, about sort of the classic Treisman and Gillette searching for T's among L's type of task. That is tricky to do with only the user interface. It's maybe possible, but it's not very convenient. And then you can use the canvas object. But there are a few big limitations. For example, due to a limitation of JavaScript, workspace variables are not shared between scripts. That means that if you create something in one JavaScript, a variable, it doesn't automatically exist in another JavaScript thing. Right? If you have two items, for example, one item for initializing the experiment and one item for initializing the trial, say. And therefore, you need to do a little bit of a hack by using kind of a container object called a persistent object that you can assign it to. This sounds super abstract. Now that I'm saying this, I think I realize that this is way too abstract. But I'm just pointing out a few limitations. And if you want to read more about that here, you can find the link below. You can find all that information. So you have to attach objects to the persistent object. Okay, but all of this is just for those of you who may want to do that in the future, not for today's tutorial. Extensively documented.
Sebastian, maybe add a bit about that. So one realistic thing that the participants want to use is to make OpenSesame work with the survey program that we have, the Lime survey. So in that case, you need to parse the identifying number from Lime survey to OpenSesame, or from OS Web to Lime survey. And that we have I've been working on that, and so we have a working demo for that, so you don't have to worry about it. So if you at some point the participants need to, hey, I want to have this kind of survey. This is an extensive survey, but I want to have a small experiment as well. Just let me know, and then there's a small script that you can just simply plug and play and put somewhere in your OpenSesame or put somewhere in your Lime survey.
Okay, that is very useful. Yeah, that is kind of similar to Lotje at some point made a screencast. That's approximately the same thing, I think.
Yeah. She actually told me how to do stuff. Yeah.
Oh, she told you. Yeah. Okay. All right. Yeah, because indeed, Lime survey basically is a different website, right? So you need to pass information from your experiment to that different website and back again, and that can be a little bit tricky. But those are the kinds of things that someone needs to tell you how to do it, essentially. And the same is true, by the way, if you use Sona systems, or if you use Prolific, or if you use other systems to sort of manage your experiment. No, let me rephrase. If you use a system that keeps a database of participants, like Sona systems, Prolific, Mechanical Turk, things like that, and you want to go from there to your OpenSesame experiment, to your OS Web experiment, you also have a similar issue where you basically need to redirect the participants to your experiment and back again, all the while remembering who that participant is, so that the participant actually gets paid, of course, when they go back from your experiment to Prolific or to Sona systems. And that requires a little bit of technical back and forth. And those are all problems that have already been solved. So basically, you will just get a piece of script that does that for you, essentially. What do you use? Do you use Sona systems? Do I remember that correctly?
We are planning to use Sona at some point.
You're planning to use Sona. Do you have a systematic participant pool at this moment?
Not yet. So that's yet another thing that I need to work on.
Okay.
But we have a survey platform, and soon we have an online experiment platform as well. Okay,
cool. Yeah. Yeah. All right. So that was it, essentially. Really. So are there any questions actually before I move on to starting the tutorial? No? Then I will.
Not yet.
Yep.
No, not yet. Thank you.
Oh, not yet. Oh, sorry. I was there. Right. Okay. So let me close this. So here I refer you back. This is the website that I made for the Venus workshop, right? And also the slides, also previous, the first day, etc., are all on here, and the slides of today. So just to refer you back to that. What we're going to do now is going to the cats, dogs, and capybara tutorial. Where can you find that? Well, you go to the documentation site. If you click on tutorials, you will see here under other cats, dogs, and capybaras. And that's what we're going to work on today. Why? Well, because I think it's a nice step up from the very basics beginner tutorial. You will learn a few other tricks, and it is also a bit shorter. And then actually tomorrow, we are going to implement yet another experiment, and there will no longer be a tutorial. There will just be an instruction, right? So create this experiment. So we're going to be, you will hopefully become progressively more autonomous, so to say. But for today, there is still a tutorial. Actually, let me first explain what the experiment is about. Mainly, I just like capybaras. That is the starting point. So this is a capybara. Capybara is apparently the largest rodent on Earth, and they live in Southern America. And they're very peaceful, and they like to bathe a lot. And in this particular experiment, we are going to have a sort of a multi-sensory integration task. And how does it work? Well, you will see a picture on the screen, and the picture can be either a dog or a cat or a capybara. And of course, we have multiple cats, multiple dogs, and multiple capybaras. Then you have to say whether it is a cat or a dog or a capybara. And you say that it's a capybara by withholding a response. So the capybaras are no-go trials, basically. And if it's a cat, you click on the left side of the screen. And if it's a dog, you click on the right side of the screen. This makes it also suitable for running it online, because when doing an online experiment, you can use the keyboard, of course. There's just like you can do in the lab. But nowadays, many people are used to using touchscreen devices to run experiment or to do stuff online, right? They will do it on their phone or their tablet or whatever. And when you have a touch experiment, basically a touch that is just a click of the mouse. So then you create an experiment that relies on the mouse, and it will automatically also work with the touchscreen. That's the idea. And otherwise, you have to put a big disclaimer saying, okay, you can do this experiment in your browser, but make sure that you actually have a physical keyboard, because it's not going to work on your Android phone. So, okay, so but this is the point. So you click left for the cat, right for the dog, and you withhold the response for a capybara. And then at the same time, there will actually be a sound, and the sound is either a meow or it is a bark. There is no capybara sound, because as far as I know, capybaras don't make a sound. They're silent animals. Maybe they purr a little bit, like rodents tend to do. And then, of course, the hypothesis is that if you actually hear a bark and you see a dog, you're super good at clicking at on the dog thing. If you hear a bark but you see a cat, you have very strong interference. And very often you will then accidentally click that it's a dog instead of a cat. So that is kind of, and of course, if you see a capybara, then quite often people will make a false alarm. They will click cat or a dog anyway. And then those false alarms are very strongly biased in the direction of the sound that they hear. I've never actually collected empirical data with this, but subjectively, this is such a strong effect that I'm pretty sure that that's what will happen. In any case, that's the experiment that we're going to work towards. I hope that's clear. All right, so I'm dragging my experiment to the side, the tutorial. I hope you all have the tutorial open. Step 1 is just getting started. And what we are going to do is start with the basics of the experiment. So here we have OpenSesame. I kind of reduced my screen resolution like the previous time. Is this good for you in terms of size? Wisnu, can you confirm that this is not too small?
I need to ask some of the people here first. Esther, is that okay?
Otherwise, I'll reduce my resolution even further. I see a thumbs
Yeah?
up.
No?
Yeah?
A
So
bit
if you're
bigger, is it possible?
Bigger, please. Thank you.
bigger?
Yes,
Is it possible?
Sebastian, thank you.
Yes, yeah, absolutely. Up. So let's go down to up. All right. I don't actually,
Oh, yeah.
what does this do to the screen sharing? Is it still sharing now?
Yeah, it's still sharing, and I don't think the font size has changed there.
Up. Up. All right.
Yeah, now it's getting bigger, right? Esther, is that okay? Yeah? Cool.
And I see,
You're good.
okay, good. Yeah. Yeah, so now I have a pretty low resolution. If I make it even lower, it will become very cramped, basically, display. Okay. So what we're going to do is first actually something really basic, namely we're going to set up the structure of the experiment, and we're going to do it more or less like we did before, but simpler. So what does it mean? From the top down, we're going to create this kind of loop sequence structure as we did in the last previous tutorial. But now we are no longer going to have a separate practice and an experimental phase. We're just going to have one huge block of trials. Is that good? No, of course, that's not good, but it's one of the extra assignments to actually make the experiment better. All right, so for the basics, that's what we're going to do. So we have here in the we have the default template. That's what we're going to start with. So if you want to start from scratch, you click on Start New Experiment. You can select what kind of template you want, and you can click on Default Template. And for me, that doesn't change anything because the default template is already loaded by default. Okay, and then I permanently delete the notepad because I don't need it. I permanently delete the welcome sketchpad because I don't need it. I'm going a little bit fast here because this is a repetition of what we've already done. And now we have a completely empty experiment. And I'm going to add one massive block of trials. And how do I do that? Well, the same way as before. I drag one loop into the experiment. I drag it and I rename it and I call it block loop. And why it's to indicate that this is going to be, right now it's nothing, of course, it's empty. But once we're done, this is going to be one massive block of trials. I'm going to pick up a sequence. I'm going to drop it into the block loop. Then you remember, you can say, do you want to have it inserted into or after? Let's actually make a mistake. If I say insert after block loop, click, you see that the sequence ends up at the same level as the block loop, but after it. If I drag it onto it and I say insert into, you see it is subtly different, but importantly different. You see that the sequence is now part of the block loop, right? And that is important because it is either sort of, yeah, inside it or after it. I don't know how to explain it better. And I rename it and I say, this is the trial sequence to indicate that inside of the sequence, we will add the elements that will make up one single trial. Right now it's empty, but that is the goal that it will have later. And then I go to the new experiment and I also rename the new experiment and I call it Binus Day 2. And I say Control S and I save it, Binus Day 2. Where does the name Binus actually refer? What does it refer to, Wisnu? I know the university is called that way, of course, but
Yeah, it's an acronym of Bina Nusantara. Like, what's the English translation of that? Developing the nation, something like that. Yeah. So.
Okay, I thought maybe it was
large vision. Yeah.
Okay, all right. I thought maybe it was a famous person or it meant it was a word in Indonesian or something. All right, that's it. So that's the end of step 2. And I think so far we have just basically a small reminder of how that works again, right? So experiments in OpenSesame have this kind of layered structure where you tend to have sequences that are part of blocks and that have multiple layers to them depending on the structure of your experiment. And right now we have a trial that is part of a block, and that block is part of the bigger experiment. And then the top level icon, that is just sort of the general container that contains everything. Okay. The next step is that we're going to add our stimuli. So I'll drag my browser back here. Oh. And then if you go to step 3 of the tutorial, if you get lost at the top, I will scroll up. Oh. You have the content, right? The table of contents. If you then click on step 3, you will jump down. And here you can click and you download all the cats, dogs, capybaras stimuli. So we'll click on it. It will start downloading. Up. And then I say, okay, show this in the folder. Now, how this works exactly, of course, depends on your operating system. I think you're probably using a mix of Windows and Mac OS, I imagine. I'm using Linux, but the idea is always the same. I go to my download folder. I right-click on it. I say extract, up. Then I have my stimulus folder. And inside you have a whole bunch of stimuli. Now, what are the stimuli that we have? We have sounds, barks. So we have the OGG files that are sounds, right? Up. Can you hear this actually? Can you hear my bark? Or should I also say share sound, right? Up.
Can you play it again?
Yeah, let me, because it's of course very nice to hear barking dogs. It's not. Can you hear that? Yeah? All right. And of course we have that's very annoying. And we have, of course, lots of cats. But what it's really about is, of course, the capybaras. Okay, And then I go switch back to OpenSesame. And remember that if you click on this thing here, or you press Ctrl P, you show the file pool. Again, we've done all of this before in the previous tutorial. You have this sort of empty container where all your stimuli go. Up, I select all my stimuli here. Ctrl A to select all of them. I drag them inside, bam. And now I've copied all of my stimuli to the file pool. So take your time to do the same, basically from your Explorer or your macOS Finder, copy paste this, simply drag the stuff into the file pool and they will be part of the experiment. All right, and I save my experiment. And remember that now, once you've done that, this means that all of those files are actually inside your experiment file, meaning that you don't have to sort of pass them separately onto your, your colleagues if you want to share the experiment. They're all bundled in one sweet kind of zip-like file that contains all the stimuli.
I'll give me some time to just confirm to all the participants.
Yeah. In the meanwhile, while you are confirming that, just so that we don't stop, let me actually ask a question to everyone in the audience. And you can cheat by looking at step 4, but you shouldn't. You should use your independent thought to kind of think what the design is of this this paradigm. So I've already explained what it looks like, right? But I'll remind you, we have 3 kinds of pictures and 2 kinds of sounds. And in the file pool, we also have exemplars of all the pictures and all the sounds. And now what our next step is going to be that we are sort of going to specify the design of our experiment in the loop table. And the design of our experiment basically is specified as a series of columns corresponding to our independent variables, and then rows corresponding to all the levels essentially of our independent variables. So can anyone sort of tell me what the exact design is that we have to specify here? So what are our independent variables? Let's start there. So I will.
Is it pictures and sound?
Pictures and sounds, exactly. That's a good start. So so let's indeed. I will use the terminology that I. So in the tutorial we've called the pictures animal. So there is one. Actually, let me click on it. Full factorial design. So then it will generate the entire design for us. So we have one independent variable that's animal, and then it's kind of obvious what the levels of that independent variable are, right? Because what are they?
Capybara, cat, and dog.
Yeah, exactly. And then for the sound also, we have what are the levels of the sound?
Bark. No sound. And sound. Or bark, meow,
Bark.
and meow.
Yeah, exactly. Right? So there is actually there's always a sound. It's either a bark or a meow. Of course, I could have also designed the experiment to have no sound. And if you want, you can add that condition. But in the way that I made it, there's always either a bark or a meow. So right now we have 2 independent variables, and they are it's a 3x2 design, right? That's what we specified here. Now, and if you would write the method section for a paper, probably you would describe this experiment as a 3x2 design, because conceptually that's what it is, right? We're manipulating 2 things. But if you think about specifying the design such that OpenSesame actually knows exactly what needs to be done, basically we need to specify more very independent variables that we are not necessarily interested in, but we nevertheless need to specify them. And what are those?
Is it congruent and incongruent?
No, because that is a useful variable actually, but it's already indirectly in here, right? Because the congruent
Oh, yeah.
the dog and the bark and the cat and the meow, and every other thing would be incongruent. No, but if you think, let me rephrase the question. OpenSesame needs to know exactly which stimuli to present, right? It needs to know more than it's a capybara. It needs to know which capybara. And that, in a sense, is an independent variable. So what do we need to specify more here? We need to specify the exact exemplars, basically, that are chosen. And we can call them in the tutorial, I call them pic number for picture number. And then it is 1, 2, 3, 4, 5. And the same sound number. 1, 2, 3, 4, 5. So, and that means that on a given trial, you might have capybara as the animal and pic number 2, and it would mean that capybara 2 is shown. And there you see that there is a slight difference between the level of abstraction, basically, at which you describe the design of an experiment. If you described a design of an experiment in a method section, you would describe it usually in a kind of conceptual way, where everyone understands that there are multiple capybaras in your set, but that's not really that important. You can also phrase it differently in statistical terms, that the exact capybara is a random factor. It is varied, but it's not something that we're interested in. It is the same thing basically as the participant, right? We also have multiple participants. They're randomly varied of sorts, but we're not really interested in the effect of participant. We're also not really interested in the effect of picture number. We just have it in there so that we don't always present the same capybara. So from a conceptual point of view, we have a 3x2 design. But OpenSesame doesn't care about the conceptual point of view. It needs to know exactly what to present. And then you need to specify, of course, everything in a lot of detail. And then suddenly we actually have a 3x2 by 5x5 design, because we have 5 exemplars for the picture number and 5 exemplars for the sound number. And this is important to kind of realize that if you start building an experiment, very often you will think, okay, in terms of this conceptual design, and sort of forget to think about the details. And then as soon as you start implementing it, you will actually find out, of course, that you haven't really thought it through, because you haven't gone down to the level of actually specifying the details. Okay, so now we have a 3x2 by 5x5 design. I click on OK. How many trials do we end up with? Lots. Bam. 150 trials, right? 3x2 is 6, times 5 is 30, times 5 is 150. This is normal. And we have every possible combination here, right? So a barking dog, where the dog is picture 1 and the exact bark is bark1.ogg. That's what it means. Okay, this is the end of step 4. And in the meanwhile, all of you have already been working on step 3 with the files, with the stimuli as well. Can you give me a thumbs up if you're with me? If you filled out the loop table. I see one. I cannot see you, all of you, due to this weird way in which Zoom displays the thumbnails. If I share my screen, I cannot see you anymore. So you have to use the virtual thumbs up in the... Okay, I see a subset of thumbs up. I'm going to assume that you are still with me. If you're not, then Vishnu will either help you, or you can ask me and I will step back. All right. So now we're going to step 5, and we're going to add items to the trial sequence. So so I click on the trial sequence here. What do we want to have in here? Well, we start, as we usually do, with the fixation dot. And a fixation dot is a sketch pad, right? And we're doing the same thing as we did before, so I'm going to go relatively fast. I pick it up, I drag it into here, and I rename this to fixation dot. Bam. After the fixation dot, we want 2 things to happen. simultaneously, but they're still two separate things. We want a sound to play, and we want the picture of the animal to appear. And this means that we need a sampler, this thing here with sort of the note in it, and that will play back a sound. And we need another sketchpad to show the picture. We can do either order in this way. You can do sound sampler, or you can do sketchpad sampler, sampler sketchpad. As long as they both have a duration of 0, they will happen simultaneously. So up, I drag in the sampler. I call this animal sound. And I drag in the picture, and I call it animal picture. After the animal picture, we want to have we want to collect a response. Now, there are various. Now we can kind of choose how we want to do this. I think it's a good idea to collect, as I already said, to collect a mouse click. And if you want to collect a mouse click, there are a few options available. You can select the mouse response, which is reasonable. And the mouse response really allows you to click anywhere on the display, and you get the coordinates of the click back, basically. There is another response element that for me is here at the bottom, that is called the touch response. The touch response also collects a mouse click, but it does so in a slightly different way. Namely, it assumes that you have actually it assumes that you have that you separate the display in a grid, and that every grid has a particular code. And now that I'm thinking about it, why don't we go completely crazy during this tutorial and actually use a touch response as opposed to a mouse click, just to kind of diverge from the tutorial, but also to kind of show you how this works. So I'm going to click on the mouse click, on the touch response, drag it into, and I will rename this up as a touch response. Because I think for our purpose, where we actually have the left side of the screen and the right side of the screen, a touch response is kind of useful, because then we basically have a grid with only 2 cells in it, namely the left side and the right side. You can also have a grid with more cells, of course. We will see that in a bit. Now, and after, we want to have the logger to actually log all the information to file, if we would run it on the desktop, or to our JTOL server if we're running it on in a browser. So I pick this up and I drop it and I rename it to logger. And now I save my experiment. Don't forget to occasionally save your experiment. Okay, so now we're at the end of step 5, and we've given content to the trial sequence, but of course we've not really configured the items themselves yet. I'm going to assume that everyone is with me, and we're going to move on to step 6. If not, then just let me know, and I will take a step back, or Wisnu will help you, and we will pick it up from there.
Maybe slow down a bit.
Okay.
1 minute, 2 minutes, something like that. Or is everyone else okay? Especially those of you who are following from home, because I can't go like visit your desk from here.
Don't be ashamed to sort of ask me to slow down or ask questions, right? Because for me, it is difficult to find the balance between not going too slow, because that's really boring, and not sort of losing everyone because I'm going too fast. So I need a little bit of feedback then to know exactly where everyone is, basically.
Aril and Surti, are you okay? So just let me make like a small round here.
Okay.
I think the people on that nest are okay, but someone else.
Sebastian,
Mhm.
I have a question just to confirm if I understood it correctly, the procedure of the experiment. So what we're going to, the first thing is we're going to see the fixation dot, right?
Yeah.
In the middle of our skin, for instance. And then we're gonna hear animal sounds, either meow or barking.
Yeah.
And then what we have to do, and then afterward, we're going to see a picture or several pictures.
We're going to see one picture that is
One
centrally
picture?
presented on the screen of either a
Mhm.
cat or a dog or a capybara. That picture will be presented simultaneously with the sound. So it is sound and picture both one. And then on the left and the right side of the screen, there will be a little circle indicating to the participant, tap here or click here if it's a cat and click here if it's a dog. And if it's a capybara, they should withhold the response. So for a capybara, a timeout will be the correct response, essentially.
Yeah, I see.
Yeah.
Thanks.
All right. Okay, let's move forward. I will go slowly, and if you need me to pause, raise your hand in the participant list or in some other way. Let me know, and then we will do that. All right, we're going to the fixation dot. This is easy. Click on the fixation dot. We have a nice black screen, and the only thing that we need to do really is click on the fixation dot element here, the fix dot element. Bop, draw it in. Oh, oops, miss. Up. Draw it in the center of the screen, and we have our fixation dot. You also have the duration. Right now it is set to key press. And what I will do is this, that would mean that it stays on the screen until you press a key. That's not what we want, of course. I will change it to 495. Remember that a display is refreshed periodically. And if you specify a duration, the actual duration on a perfect system will be the next possible moment that the display is refreshed, which on normal displays that refresh every 16 milliseconds, so 60 times per second, would mean after 500 milliseconds. So de facto, we're specifying a duration here of 500 milliseconds. If you run this on a nice laboratory computer with a good graphics card, this will work perfectly. If you run it in a browser, where everyone will run it on their, their 5-year-old Asus Transformer laptop notebook, in the browser, with all kinds of browser extensions installed, of course, the timing is not going to be perfect, right? But that's what this means. Now, the next thing is the animal sound. So I click on animal sound. And then here, you get a few things that we need to specify. Most of it is very trivial, but we will go through it anyway. So the most important thing, of course, is the sound file itself. So I click on browse, and that will open a browser, but it will browse only our file pool, right? So not a file from disk, but our file pool. And what I will do is I will just select one sound file. So bark1.ogg. This one sound file is, of course, not what we want to, we don't on every trial want to play back bark1.ogg, but we want to have this depend on our independent variables. So how can we actually, as a question to the audience, how can we actually change this so that we don't always play bark1.ogg, but we play the correct sound file depending on our independent variables? How would we do this?
You just name it bark and then somewhere specify the number.
Exactly, that's a good point. So one small user trick, if you click on this button, then you will sort of put one of the items aside, and then you can select another item and you can sort of put them side by side. That can be kind of convenient sometimes. So that's what I'm doing now. So here we have our block loop, and here we have the configuration of our animal sound. And what you are saying is that you want to have bark, and then this number you want to actually change by a variable, right? So how would you do that? You refer to variables by putting something between square brackets, just like we did previously for the during the gaze queuing tutorial, but now we're doing the same trick in a sampler. And then in between the square brackets, we put the name of the variable, and that would in this case be sound number. Now, and this goes some way in the direction that we want, because we would now play bark 1, bark 2, etc., depending on the sound number, right? So here we would play right here we would play bark 3, for example, on this particular trial 74. But we're not completely done yet, right? So what else do we need to do here? It's very derivative. Do we always want to play back a bark?
No, we also
No?
need the meow.
Yes, we also need the meow. So how do we need the meow? How do we actually do the same thing, but then indicate whether we have a bark or a meow?
You put the name of the column there.
Exactly. So instead of saying literally bark, we put another square brackets and we say sound.
Sound.
And now, for example, on trial 5, right, this one, we would actually play bark 1, right, because sound would be replaced by bark and sound number by 1. And here, for example, we would play back meow 1, etc., etc. Right, so we're basically using now 2 variables to actually specify the sound file. The result should actually map onto a file that exists. So the .ogg is necessary because the files are called .ogg, right? So that actually needs to be part of it. All right. I hear that someone in the neighborhood is making some kind of drilling noise. So if you hear that, I'm sorry about it. So then we have a few other things. Is it possible for the sound format other than OGG? Yes, it is. MP3 and WAV are also supported. It used to be that only OGG and WAV were supported, but now MP3 is also supported. So basically, yeah. The volume is just how loud it should be. The panning is whether it's left or right. The pitch is whether it's fast or slow. Stop after means that it's basically say that you have a very long piece of music or something and you only want to play the first 20 seconds, then you could use this. The fade in is how slowly it should ramp up. And the duration, by leaving these at 0, we just mean they're played infinitely. And the duration, that's the only one that's important for us, for our purpose right now. It's a bit counterintuitive, I have to admit. But what it means is not how long the sound is actually played for, because that is the stop after parameter, but how long the item should wait. So by setting it to sound, it means that this item will block until the sound is done playing. That's not what we want. What we want is we want the sound to start playing in the background, essentially, and then the experiment to move on immediately, right? Because while the meow is still meowing, we already want the participant to be able to click. So I will change this to 0. And that doesn't mean that it is actually only played for 0 milliseconds, but it means that the sound starts playing in the background and immediately the experiment moves on and the participant can click on the can give a response. That's what it means. I hope that's kind of clear. I appreciate it's not super intuitive, but that's what it means. All right.
So it's the same trick with presenting pictures, right? So we also set it to 0, but it doesn't mean that it's shown for 0 seconds, but it just immediately moves on to the next object, which is the keyboard response to the click.
Yes, absolutely. It's exactly the same as with the sketchpad. All right, close this. I show my up. So if the overview area, you can sort of hide and show it again by clicking on this button. I will do that occasionally because my screen is so small right now that it gives me a little bit more space to show things. So if you're asking where did the overview area go, that's where it went. Okay, so now we've specified the animal sounds. Now we need to do the animal picture. So the animal picture is more, we are going to do something very similar to what we did before when we specified, when we did during the gaze queuing tutorial. So I click on the image element, I click on the center of the screen, and I select one capybara. Bam, there it is. Now, of course, we don't want to specify only this capybara, but we want to actually specify a specific capybara that is that depends on our independent variables, right? So let me actually say split view. Then here at the bottom, you have the script that corresponds to this capybara, and you see, I'll make it a bit bigger, so it's clear for you. You see, we draw an image at the center of the screen, and the file is capybara1.png. The scale is 1, blah, 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 blah. So just to kind of, how should we change this now? Basically, the file that we're showing, to make sure that it actually shows the file that matches what we want to see on a particular trial. Between square brackets, I see Pinkang making square brackets. Can we narrow it down to a more specific? So what exactly should we type here? You can type it in the chat also, of course.
Animal and picture number.
Exactly, yeah. Animal number, yeah. And if we, so I see a few partial solutions in the chat. Animal, and then pick number. Of course, the exact names depend on how you named them in your block loop, right? But I indeed used, I think so at least, use this animal to say capybara and pick number. Is this going to work? Is this enough? Would this work if I'm trying to do it like this? Yeah, think about what are the files actually called. If I
the dot PNG.
.png, exactly,
Okay.
because the end result needs to evaluate to the name of a file that actually exists. So now it would indeed evaluate to say dog3.png, and that exists. But dog3 by itself doesn't. That's not the name of a file.
Okay.
All right. So other than, now you see here in the center, we have a question mark. That is not because we made a mistake, but it is just because OpenSesame doesn't know how to represent files that have been defined using variables.
So Sebastian, just a small clarification. So sometimes people have the extension of the files hidden in Windows, for instance.
Oh yeah.
Would it matter
point.
once you put it in the file pool, would you see the extension, or do you need to view it first in Windows, for instance?
What did you say? What did you say at the end? I didn't catch that.
So if someone has a setting of the extension off in Windows, if they move the file to the file pool in OpenSesame, would they be able to see the extension, or
yes.
they need to open it first?
No,
Windows?
so in the file pool, you will always see the extension. But it is true that it's a bit confusing, perhaps, because it will seem like the file is actually called, capybara1 without an extension, and then you suddenly see that it has an extension. But the file pool is correct, so to say. It's just that Windows is hiding something from you because Windows feels that you're not intelligent enough to be able to deal with the concept of file extensions. But for OpenSesame, you need to be exact. It will not guess the file extension. Okay, yeah. Now, and then we want to give the participant some kind of clue that that you need to actually tap one side of the screen for a dog and the other side for a cat. Now, I suggest that what we're going to do is be very liberal and basically say the left side of the screen is a dog, the right side of the screen is a cat. Of course, in a proper experiment, you would counterbalance that between participants. That's one of the extra assignments. But for now, we're just going to say left side dog, right side cat. Up. And to give a hint, what I will do, but you can do this in any kind of way, I will draw a circle here. I will fill it. I will give it a nice color, because I think it's nice to give things nice colors. And then I will draw a text in here, and I will say dog, exclamation mark. And I will make the dog a different color because, it's nice to have a different color. give it the big font size. And I just encourage you to make this look a little bit nice for your participants, you know, just give draw some kind of indication on this sketchpad that the left side is for the dog and the right side is for the cat. Up, and here I draw it in the center, -325, up, so. Now, I think for the cat, I think cats are more green, maybe. Up. Cat, exclamation mark. Up, select a nice color. All right, now. So these things, they don't really have any specific meaning for our experiment. They're just for the participant to tell the participant what to do. If we would run this on the desktop, we could actually give it a special meaning. Then we could select this. We could give it a name. We can do that now anyway and say, okay, dog target, let's say dog target. And we would call this the cat target. And then we could automatically have OpenSesame recode a response based on where they tap on the screen. But because we're going to run this in a browser, this kind of functionality is not available. And we are just going to rely whether they tap the left or the right side of the screen. Now, the final thing that we need to do is change the duration. Right now it's set to key press, and I'm going to set it to 0, not because it is only shown for 0 milliseconds, but because we want to show it and then immediately move on to the touch response to actually collect the response. So I hope that's clear. And I save the experiment. Are there any questions about this? This is basically the most complex part of the experiment. So, no?
So in the previous experiment, so you explained it a bit. So in the previous experiment, we defined the correct answers in the block loop, but in this particular experiment, because we're relying on a touchscreen and a location, we will determine the correct responses later on once we have defined these two locations, or how do you want?
So this is a good question, actually. Let me get back to that in a bit. So we're diverging a little bit from the tutorial, and that also makes this question a little bit, means that we have a slightly different answer. But it's a good question. So it's basically, how do we define a correct response? Now, but that's related to the touch response. So let's first take a look at the touch response. So what we have, if you have a mouse click, if you use a mouse response, then the response will become the meaning of the response. So if we would select this item here, the mouse response, the response would mean which mouse button you clicked, the left, the middle, or the right, 1, 2, or 3. This is actually very rarely what you're interested in, because virtually always people click with the left mouse button, but that's what it means then. So then if you're interested in where participants clicked, indeed you have to analyze their cursor location and sort of manually recode whether the location that they clicked on was correct. The touch response in this respect is slightly more convenient, because it allows you to specify a correct response in terms of a grid. What does this mean? Well, it means you can specify an X number of columns. And if we have 2 columns, it means that we have the left side of the screen and the right side of the screen. If we have only 1 row, there is no division along the vertical, right? If I would say 2 rows, it would mean top left, top right, bottom left, bottom right. And then it would go to responses such that it would go 1, 2, 3, 4. If we only have 2 columns, it would go 1, 2. And you see how that logic generalizes, right? If we would have 3 by 3, it would go 1, 2, 3, 4, 5, 6, 7, 8, 9, for example.
And the grid always starts from top left to bottom right.
Yeah, the coding is sort of in the reading direction, so to say. In the reading direction for us, not for left to right, right to left languages, of course. What we say is 2 and 1. Now, that means also that we can specify our correct response simply as 2 and 1. let's leave that for one of the extra assignments. It basically means that you can go to the block loop, add a correct response column, and call it 1 or 2, depending on whether it's a dog, which should be 1, left side of the screen, or a cat, which should be 2, right side of the screen. And then you can become more fancy and counterbalance that between participants, etc., etc. For now, we leave it like this. Now, and then there's also, of course, a timeout, which right now is infinite. So if you think about the design of the experiment, is this touch response currently suitable? Or is there something else that we need to change? Especially think about the kind of response that they need to give, participants need to give if they see a capybara. So what is the correct response for the capybara?
You don't have to do anything, so it's a timeout.
It's a timeout, exactly. So the correct response is a timeout. So what is the problem that we're going to run into now?
We don't have that option.
No, there is no timeout. So the participants will either have to make a false alarm or wait infinitely. So what we can do is say, okay, we give them a timeout of what is reasonable. I always think a timeout between 2 and 3 seconds is reasonable, depending a little bit on how fast you expect participants to be. Let's give them 3 seconds. Of course, if we make it very long, it will be super boring, right? When they see a capybara. So maybe, you know what, let's make it 2.5. 2.5. Okay, so, and what would that mean? Well, the correct response would be a 1 for a dog, a 2 for a cat, and a none with an uppercase N for a capybara. Okay, now here we have a logger. Right now the logger is set, oh, sorry, I'm going too fast. So now we've configured the touch response. Are you all with me, or are there questions about how this works?
So if you put none, so not a number as a response, they would evaluate exactly, even though it's a string, because then we put it as a string in the loop, right?
So so it's actually not spelled. Let me just show you what I mean. So I would add the correct response column here. For the capybara, it would be none. For the cat, it would be 2, and for the dog, it would be 1. That's what I mean.
And it will evaluate none as a correct if I skip, right? Because I don't give a response.
Exactly. So none is like a dummy key that is pressed when the timeout occurs, basically. And then you would just replicate this column all the way to the bottom to basically define a correct response. Let's remove that column. That's what I meant. So not none, N-A-N can indeed also mean not a number, but that's something else. That's a mathematical concept. And here we're just talking about the string none of like nothing, none. All right. Now, the final thing that we need to do is click on the logger. Right now it says log all variables recommended, but this is recommended when you don't run it in a browser. If you run it in a browser, this is actually not recommended because it will mean that a lot of unnecessary information is sent back and forth to MindProbe. And that is just basically costing us money and server load, considerable amounts if you in some cases. So you will also see that if I try to run this now, say that I try to click run in browser, bam, it will actually say compatibility check failed. And it will give a few warnings actually. It will say that the experiment is a bit big. And it will also say, it doesn't say that actually, but it should say, oh yeah, it gives a few warnings that the experiment is pretty large, and we're just going to ignore that in this case. And also that the logger, to save bandwidth, select only relevant variables instead of logging all variables. So that is kind of what the kind of feedback that the OS Web extension gives you if it's not entirely satisfied with the experiment, basically. Let's go back to the logger. So I will disable log all variables, and then I will actually cherry pick a few variables that I want to select. This is kind of useful to know how that works when you want to run an online experiment. I will click here on Show Variable Inspector. And here, the variable inspector shows a lot of variables that exist in the experiment. Some of those are important, some of those are not, right? For example, that the background is black is not terribly important. I don't think we need to log it. It's just fixed. It's not something that varies. But what is important is, of course, the animal that is shown on a given trial. We definitely want to know that. So I pick up the animal and I drag it into the logger. What else is important? Well, the correct is important. It indicates whether the participant was correct or not. It actually only is important if we've defined the correct response, which we haven't done yet. So right now it will always be NA, non-defined, but if you would define the correct response, this would be important. Cursor X and cursor Y, that is exactly where the participant clicked on the screen. Is that important? Well, it's not crucially important because we're mainly interested in whether they clicked on the left or the right side of the screen, but it's the kind of thing that maybe we want to save just in case. So let's drag it into the logger. What else? Pic number. We want to know what the number of the picture was that was shown. We want to know what the response was, whether it was 1 or 2, right? Left or right side of the screen. We want to know the response time, how long they took to respond. We want to know the sound, whether it was a bark or a meow. We want to know the sound number, whether it was 1, 2, 3, or 5. We probably want to know the subject number, although it is actually randomly chosen by OpenSesame. So I should say a word about that actually. If you start the experiment on the desktop, of course, you select the subject number, and that's the subject number. If you run the experiment in a browser, you don't really have that option of having a linearly incrementing subject number. Basically, you start it and the subject will get a random ID. Nevertheless, there is kind of like a dummy subject number that is randomly chosen from a subset of subject numbers. If I go to Tools, OS Web, you will see here possible subject numbers, 0, 1. It will mean that every time that the session is launched, randomly, the subject will either be 0 or 1. This is not terribly useful, but it can be useful, for example, if you want to do counterbalancing such that half the experiment, half the participants have one response mapping and the other half of the participants have another one, so to say. But in any case, the subject number means something different when you run it in a browser from when you run it online. I hope that is clear. Okay, are there other things that we want to have? No, that's about it. These are the things that we're interested in. And you see that by actually cherry picking these variables, we have an experiment that is, we require much less communication and data transfer with the server than we would if we would log everything on every trial. And that saves a considerable amount of data. All right, I'm going to save it. And now we're essentially really good to test the experiment and then take a break also afterwards. But I first want to ask you if there are questions.
Yes, please, Sebastian. If I may go back a little bit, I have a problem while copying the correct answer. I saw that you did it quite quick, but when I copy and paste, why it wasn't correct? Oh, now it's gone. You haven't done it yet.
I don't know I don't know exactly what you did, of course, so that's difficult for me to say. But how I would do it, I would just type correct response, and then I would manually just type here under capybara that the correct response is a null. You don't need to do this, by the way, right? This is not necessary for the experiment to run, but I will show you anyway. For the cat, it would be a 2, and for the dog, it would be a 1. Now, and then I would select all 3 of them and copy and then paste. And I would select all 6 of them and I would start using my keyboard and say paste. I would select all 12 of them and I would say paste, paste, and I would just go pretty fast, select all 36 of them. You see how with a little bit of clever copy pasting, you can go a long way here.
Yeah, it's okay. I did that, but then I don't know why the number wasn't correct. So I have extra 2 rows. But maybe I made a mistake somewhere.
Did something like this happen? That you had trailing? Yeah. Okay. So basically,
that's extra 3. So that's correct. I have extra 2. So
it is in any case not correct. you should have exactly 150 times 50 rows. If you have more than 150, it means you have a little bit of excess baggage basically at the end, and that will cause trouble, because you will see, of course, that this row 150, which the number is not shown correctly, but this will be 152. There is actually no picture, and there is no, so that is not good. So what we want to do is select all of those, right click and say remove 3 rows, so that we end up with exactly 150 rows again. You see what I mean?
Yeah.
So there should be, the number here should say trial sequence will be called 150 times. And if it says another number, it's not correct. Does that clear things up?
Yeah, thank you.
All right. Okay, are there other questions? No? Then let's actually test the experiment. So now we've done all the basic tutorials, and the extra assignments that you will see at the end are something that you can work on later if you want to kind of hone your skills, but at least you have a basic experiment that runs now and that we can use to run also in a browser. So what I will do now, I can click it. Can click here on run in browser. If I do that, it will actually start a browser up, and it will say OS Web 1.4.7. Ideally, it will say also for you 1.4.7, then you are running the latest version, but at least make sure that it is 1.4. And then something in the upper regions. Actually, let me say a word about updating that later, because sometimes OS Web is updated a little bit more often than OpenSesame itself, and you can update them separately from each other. Let me say a word about that. In any case, let's actually try this out. Okay, this is a cat. This is a dog. Capybara. No, capybara. Cat. Oh, you see that I wanted to click again. Super powerful. Okay. 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 I think you get the general idea. I click cancel. Okay, escape. Cancel. And now the experiment stops. So you see it works, right? What should I say? What else should I say about this? So right now, at the top, you see the link to my experiment. For you, that link will be different, but it will also be something temporary, some link to your temporary folder on your computer. Don't pass this link to participants. It will not work for them because it literally refers to a file on your own computer. And after the break, we will see how we can actually upload this experiment to MindPro. Yes. What else should I say? If a little bit of a technical thing that is useful to know, all of these things you can read back, right? So I'm overwhelming you maybe with a little bit of information here, but at least you know where to start. What can happen quite often, and it will happen all the time, is that your experiment crashes. If you run the experiment on the desktop, you get usually quite a nice error message. If you run the experiment in a browser, the error messages are generally much more difficult to interpret. But one way to get a better idea of where the error messages come from is to click here on developer tools in your browser. Every browser has that. Where they are, where that option is, depends a little bit on the browser that you're using. But in Chrome and Firefox, you can find it as developer tools under Ctrl+Shift.I. If you click on that, it will open a sort of extra console, basically, that is like the console in OpenSesame, but then for your browser. And actually, this is a JavaScript console. You can type JavaScript stuff in here, and it will execute that. But it will also show output from the experiment. Output that you otherwise don't see. This output is the stuff that would normally be logged to JTOS, right? So there are variables, basically. But you will also see that if errors occur, that they are shown in red here. And you may be able to understand what those errors mean, And also, if you, for example, post a question on the support forum, it is useful to post that information along with your question, because even if for you it is difficult to understand what the error means, the people on the forum will be able to help you better with that. So that is useful to know that a lot of the magic basically happens here in the JavaScript console. Okay, I think that is a good moment to take a break. And then after the break, we're going to take a look at MindProbe. In the meanwhile, I'm going to create MindProbe accounts for all of you during the break. This is for that purpose. It is important that you fill out your details on the participant list. So Vishnu, can you give access? Can you post a link to the participant list again in the chat for those of you who haven't done that yet? And then I will send all of you a private message through the Zoom chat with your password. So your login will be your email address, but the password, of course, will be your private, will be for you personally. Yeah, Vishnu, can you do that? And then also ideally
an easier
also
way would be to make certain format for the password. For instance, your last name _ something, so that you don't have to. Yeah, well, if you're not. If you're okay with that, of course. But if you don't mind sending messages for each of us, that's also fine. For some of us have accounts already, so that might make it easier for you.
Maybe you're right, actually. And then the reason I suggested that is mainly because then you don't have each other's password, right? Okay, yeah. But let's do it like this. Indeed, those of you who need an account, post your email address here in the Zoom chat. I will create an account for you, indeed, with with just your password will be your last name, and then you log in and immediately change your password to something that only you know. So don't leave your password to something that people can guess, right?
Yeah. Yeah.
So action point for all of you: post your email address in the chat if you need a MindProbe account. If you already have a MindProbe account, of course, you don't need to do it. Okay? All right, I see a few thumbs up. And then in the meanwhile, we're going to take a break. And let's say that we reconvene. Let me show the schedule. So what we have after the break, online experiments, 14, I'm losing time, but it is 14:40 for you now, right? Am I correct? Yeah, it should be. So let's reconvene at 3 p.m. Thanks. All right. And then I'll make a cup of coffee and get you those MindProbe accounts.
Thank you. See you in 20-ish minutes.
Yes, see you in 20 minutes. Up. All right. Yeah.
Good reminder. I totally forgot.
Yeah. Okay. So I see your question, Pinkan. So what we're going to do now is take a look at how we can actually upload the experiment that we just created, even though it's not perfect yet, right? You still haven't done all the extra assignments, etc. But you have a working experiment, I think. And if not, then you can work on that later. I'm assuming that you're helping. I couldn't read that, of course, but you have a working experiment. And the sound is not heard at the same time. Okay, let's get back to this later, Buddy. Now we're going to focus on the on MindProbe. Just set the duration back to 0. So what we're going to do now is take a look at how you can actually upload your experiment and distribute the links. So what I did, I went to mindprobe.eu. This is basically just a welcome page, and it has a bit of information about the server. So if you don't have an account, you can request it, but I already created an account for you because it takes a little while actually to get the account if you request it. You can get support. We'll just put you to the support forum. What is also important if you're actually going to use this for an experiment are the privacy and ethics and the terms of use. So basically what the privacy and the ethics say are that this is we do nothing with the data. It's just provided as a free service and we don't track you or do anything else with it. And this server is located in Frankfurt, basically hosted by a company called DigitalOcean. So this Frankfurt is a city in Germany, so it is within the European Union. But for a lot of, I don't know whether that's also as much the case with you as it is here, but in Europe, there's a very strong focus on privacy and ethics, and most universities have like an ethics or privacy officer that needs to be okay with you actually using a service like MindProbe to store scientific data. But for, of course, this purpose that we have now, that's fine. Now, okay, so you click on login. Then you go to a login screen. And the login, for those of you for whom I've just created an account, is your email address as you posted in the chat. And your password is the account associated with that. So if it would be sebastian@binus.edu, then the password would be Sebastian. And the first thing that you're going to do if you log in is change it, of course. Okay, so I log in. You get you're welcome. Now, what are we seeing here? As I said, first thing I'm going to do, if you just had this new account, you click here in the top right. I'll zoom in a little bit. In the top right, you click on your own name, and then you say, change password, click, bam. And then your old password is what I gave for you, and your new password should be something that is fairly safe, all right? And then you change it. So that's for those of you who just got an account, is your first point of action. Okay, assuming you've done that, we're back at the welcoming page. Then we have a overview with on the left, you have all the experiments that you own. So here you see I am using MindProbe a fair bit. So you see I have, say, 20 experiments or so on the top left. And here at the bottom, you can create a new study. You would almost never do that. Creating a new study means essentially building a study from scratch. And the workflow with OpenSesame is that you import a study that OpenSesame has created for you. And what is a study? A study is basically a combination of some metadata, some additional information, plus of course some JavaScript code for JTOLs to execute. And the administration thing you don't have because you're not an administrator. So let's take a look before we actually upload our own experiment. Let's take a look at how this would work. So for example, I have a visual search experiment. I click on it, and then it opens some properties of the experiment. All kinds of things that you can do. It has a run thing, a run button. If I would click this, it would run the experiment. We can do this for fun. I click on it, up, and then you will see that it will load, bam, click, and you will see that it gives some instructions. And what this is basically a demo experiment that is part of a tutorial also on the OpenSesame. And it's like a visual search task where you have to find a blue square in this case. All right, escape, cancel, and then I'm going back. And you see study finished with message, experiment aborted by user. Now, this run button is just for you to test the experiment in JTOLs. It is not for you to actually generate links to participants. Then we have a button.
About the chat.
Okay. Then we have a button that says study results 229. I click on it. And you see something that we will take a look at in more detail later. It is basically a database with all the data that was logged from people participating in the experiment. So now there are 229 data files. You see that it has lots of information about it. You see it has a state. The state is kind of important. And the state should ideally be finished. But you will see that in this case, there are very few things that are actually finished, because it is kind of like a demo thing that people click on, but they don't really finish the whole experiment, if you see what I mean. But if you would actually do this, if I would show you the data from a different experiment, what would be a good example? The deep color is one. Study results. This is an experiment that I actually conducted for real, so to say. Then you see that here we have one that is actually finished. Sonas, and you will also see, yeah, I did this through Sonas systems, and you will see these are all finished things. Those are from participants that actually finished the experiment. These data things tend to be fairly messy, because people are very inclined to actually click on a link, start the experiment, and not finish it. So you tend to end up with lots of sort of unfinished data, and then you cherry pick the finished things out of it. That is kind of the idea. And you see that also here. Or what people will do, they make all kinds of assumptions that don't work. For example, they will start the experiment and then think, oh, I want to try again, and they refresh the page, for example. That's not allowed. That will cause the experiment to crash. And then you will have you will also get the failed thing. So in any case, this is what the data looks like. And then you could say export the results, download all the data, and then you could analyze it. And we will see how that works in the fourth day of the tutorial. Now let's actually just go back to the overview. And now this is an existing experiment, right? I showed you the visual search experiment and now this deep color experiment. But how do you actually upload your own experiment to this? Well, the first step is that you go to OpenSesame. What you cannot do, and you might be inclined to try this, is click on import study and try to import the OpenSesame experiment. That won't work. It will not import OpenSesame experiments. It's a different format. So I first switch back to OpenSesame, and here I have my experiment. Then I click on tools and I go to OS Web, and I have this panel that gives me a bit of information about my experiment. And in principle, it's fine, although actually it gives me a warning that the experiment is pretty big. And you can imagine that if you would do this experiment and you would have actually lots of pictures, it would actually easily become too big. And then you have to think, for example, use JPEG instead of PNG to compress the files and things like that, you know. But the more important thing for our purpose, we've already seen the test experiment button, but the important thing for our purpose now is export experiment as JTOS study. And if I click on this, it will ask me to save the experiment, and you will see it will save it as the name of the experiment, .zip. Why a .zip? Well, because a JTOS experiment is basically the OpenSesame experiment bundled together with a bunch of other stuff in a zip file. That's what it is. And I save it. But experiment successfully exported. Now, once you've done that, I'll give you a moment actually to catch up. Are you all with me? So basically, you have your experiment, you go to Tools, OS Web, and then you say export experiment as JTOS study, and you save the result somewhere. I saved it in my downloads folder. I'm going to assume you're all with me and switch to MindProbe. Well, okay. So now I'm here back in MindProbe, the website. I click on import study, and I just go to my downloads, and I select not the OpenSesame file, -day2.osx, but -day2osx.zip. And I double click on it, up, and then it will actually upload it. And it takes a little while, right? Because I'm uploading 10 megabytes to the server while I'm doing Zoom at the same time. Import, Yes. Well, and then it will give you a message, newly imported study, minus day 2, with study assets, blah, 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 blah. Go to this study. So I'll give you a short moment to catch up. So the logic is here. You click on import study, not new study, but import study. And you select the zip file that you have exported from OpenSesame. That is the logic. Then it will upload it. All the information will take a little while if your connection is not super fast. And then once that's successful, it will give you this message and you can say, oh, oops, cancel. Go to this study. Boom, there we go. And now you see here on the left side, I have my minus day 2. This is the study that I just imported. There are no study results, blah, 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 blah. Okay, are there any questions up to this point about how this works? Okay, then of course, now the next step is how do you actually go from here to giving links to your participants? Now you already see, of course, this kind of green button, study links, that is obviously where you want to go. So let's click there, well, study links. And then we get this kind of panel that is a little bit confusing maybe, but that's because JTools is a very beautiful piece of software, I think. And it allows you pretty fine-grained control over how you want to distribute links to participants. So, and here you have what are called workers. There are 5 different ones. And each worker is basically a specific logic, or it has some restrictions. That's how I should say it. Has some restrictions about what you can do with the link. So what can we say? The personal single worker can run a study only once. So basically you get a link to the participant. For a participant, each participant has an individual link. So you need to create as many links as you want to have for the participants. And they click on it once. They need to finish the experiment. And that's it, basically. So this is super restrictive. And of course, it's mainly if you want to have very fine-grained control, right, over your experiment. Say, for example, that you have, I don't know, you have a study with a select group of elderly people that you specifically want to test. And you want to test them you want to make sure that you give them one link, they click on it, they do the experiment exactly once, no reloading, just a clean, almost laboratory-like setting. Then you would use that personal single worker. I've never used it for my own research because I don't do experiments of that kind. So it's super restrictive. How would you get a link like that? Well, you would click on study links here. And then you would say, okay, well, I want to have, what's the difference between, you could say, okay, I want to have new study links. I want to have, 3 participants create. You would get 3 links and you would send those to the participants that you want to test. I hope that logic is kind of clear, right? So you would just copy this and literally by email, for example, send it to a participant and say, well, click on this link, make sure that you complete the experiment once you start it, because you cannot reload it and you can use the link only once, blah, blah, blah. Okay. The personal multiple worker. So is that they're typically, now let me not. Yeah, so the personal multiple worker is that you basically get one link that can be executed only once within a browser, but multiple times on different browsers. So that's basically what you do then is you add a restriction that you don't want the same participant to do the experiment multiple times, but you want to reuse the same link for multiple participants. In principle, that's a reasonable thing to do. Again, I've never actually done it. The general single worker is the opposite of it. It is one link that a single participant can click on as often as they want in the same browser, but different participants cannot. So you allow one participant to do multiple sessions, essentially. And then you have the general multiple worker, and that is the link that I always use. And that is basically anyone can click on it as often as they want, essentially. And how do I then keep control of who does the experiment? Well, I do that by actually looking at whether the experiment was completed, and also by linking the experiment, for example, to Sonas systems or to Prolific or to some other service that allows me to actually link back the results to specific participants. You see that on the left-hand side, there are these checkboxes. I click on General Multiple Worker to actually, because by default, it is not actually enabled, so the links won't work. You actually have to explicitly say, okay, I allow this worker. Then I click on Study Link here, up, and there is only one link. And again, this link, you can just pass it on to participants. You could put it on Sonas systems, on Facebook if you want, whatever. You just pass it around. Few things that you can do. You can say open directly, or you can say confirm first. If you say confirm first, then literally they need to confirm. It can be a bit convenient because, you know, people are so inclined to actually, as soon as they see a link, to click on it and immediately cancel it again. So this adds a little bit of an extra buffer between it. If you want to be fancy, you can also have a QR code, and you can put it on your poster, for example, if you think it's cool that participants or people at a conference can, you know, whatever you want to use the QR code for. All right. Now, and how does this work actually? It is very simple. I just copy this. I just go to a new tab. I paste that link, and that's what essentially the participants would also do, of course. I go there, and now it will start my cats, dogs, and capybara experiment. So I don't necessarily want to do all 150 trials, right? But I will show you a little bit how this goes. You saw that the loading took a little while, right? That was that 10 megabytes being downloaded basically from MindProbe to my computer. And be a little gentle on MindProbe, please, because we slash the European Society for Cognitive Psychology are basically sponsoring that server space. And we're talking about hundreds of thousands of participants doing experiments. So you have to imagine that if each participant downloads 10 megabytes and uploads 10 megabytes in terms of data, that's already 100,000 times 20. How many? What are we talking about? We're several gigabytes.
That's a lot of megabytes. So I would say to the participants here, if you want to try it out for pilot testing, go ahead. But please don't use MindProbe for data collection, because soon we will have our own server.
Okay, yeah, that's a good point. But everything that you see here on MindProbe will generalize to that server. Okay. All right, so I'll do one cat. No, was not. She's all there. All right, dog.
Cats all the way down.
Yeah. All right. I'm going to say escape.
That's a grumpy cat.
Cancel. All right, I'm aborting. A problem occurred, experiment aborted by user. It's not really a problem, it's just what I did, right? I pressed escape. If I now go back to JTools, and I go, so I hope this is clear, right? So what I did is basically I pretended that I was a participant and I clicked on this link. That's what I did. Now, if I now go back to the main panel, you see that I have one study result. Where does that come from? Well, that was me. That was me just now doing the task. If I click on it, you see that it says fail, experiment aborted by user because I aborted the experiment. Nevertheless, I did a few trials, right? So I did it for about 1.5 minutes. And here you can see actually what the data look like, basically. So you see that in a format that is very difficult to read, all that data has been logged. And what we will do on day 4 is see how you can download this data and basically convert it to a format that you're more familiar with, just a spreadsheet, and do a repeated measures analysis on it, essentially. But this is the format in which the data is logged in the database. And you can recognize that it has the information, right? Animal, capybara, correct is 1. The cursor coordinates are not stored actually by the touch response. I didn't even know that. Picture number, blah, blah, blah. Oh, wait, no, they are. It's just that there was a timeout. But on trials where I did click, you see that there is a cursor X and a cursor Y. All right. Well, this is essentially it. This is all there is to it, to running an experiment online. What makes it difficult, of course, is to design an experiment that runs well online and that keeps the attention of the participants and blah, 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 blah. But the general principle of running an experiment online is quite simple, I think, as you can see. Are there questions about this, or things that you would like to say?
So, a bit of a technical thing. So if we go back to OpenSesame, there are different options for backends, and maybe some good overview about like which one do you want to choose for offline experiment, online experiment.
Ah, okay, yeah, this is a good point actually. So the backend, if I click on it, it is sort of the technical layer that runs it is the software that is used to actually do the stimulus presentation, etc., when you're running the experiment on the desktop. PsychoPy is a Python library for visual stimulus presentation, also has a graphical user interface. You can use that, that's the default. Legacy is kind of an old-fashioned based on another library called Pygame. The details don't really matter. Offers a less accurate timing, but it is a little bit more stable. Experiment uses yet another library that is called Experiment. And then Psycho_Legacy is basically, there were some updates to PsychoPy. And if you want to use kind of the old-fashioned way of PsychoPy, then you choose that. Well, my recommendation would be, if you're interested in good temporal precision, use the Psycho backend. If you run into some issues with that, then you can also choose, for example, the Legacy backend or the Experiment backend. It is a matter of choice, basically. It is, in many cases, it doesn't really matter. But it relates to the underlying software that is used to actually present the stimuli on the display. That's what it relates to. In terms of running an experiment,
like an Android backend, right?
There used to be an Android backend. That is true. So then, if you wanted to run the experiment with an Android app, you needed to select a specific backend for that. That Android app no longer exists, and that backend also no longer exists. If you now want to run an experiment on an Android device, I would say make an online experiment and run it in a browser. When you run an experiment in a browser, the backend is not applicable, because the backend is the browser. The browser is the underlying software library that basically, basically determines how you run the experiment. So it is a bit confusing, perhaps, but this backend option, just like several other options actually in OpenSesame, are not applicable to online experiments. They don't change anything. The only thing that they do is when you run the experiment on the desktop with one of these 3 buttons, then it determines which underlying software library is used to run the experiment on the desktop, basically.
So the timing of my experiment for an online experiment would be entirely dependent on the type of computer and the version of the browser and whatnot of the participant. Yeah.
So when it comes to temporal precision, on the desktop, the backend is very important. Of course, the most important thing at the end of the day is the quality of the computer, right? If you have a very old computer, it's going to be a bit off anyway. But assuming that you have a good computer, the Psycho backend gives you the best timing probably, or the Experiment backend. Usually they're both perfect, so it's not really that one is much better than the other. The Legacy backend, on the other hand, is less perfect. When you run it in a browser, it indeed depends on the browser that you have, and also the number of other things that the user is doing at the moment, the participant is doing at the moment, because you know how people are with browsers, right? They have a gazillion tabs open at the same thing and notifications popping up, etc., etc. It depends on the speed of the computer. It depends on, so you cannot assume perfect timing when you do an online experiment. And there are kind of 2 separate questions here. The first is, if you have a very fast computer in the lab and you use the browser to run the experiment, is the timing good? Yes, probably it will be quite good. It will maybe almost be as good as if you run it using the desktop. But of course, when you run an online experiment, that's not the context in which most participants are running the experiment. Most participants are doing it kind of on their own computer, their little, 6-year-old notebook, while they're doing WhatsApp at the same time. And then, of course, you cannot really assume good time.
So
that is-
as a general rule, maybe we shouldn't design a between subject experiment for an online experiment, for instance.
Between subjects. Yeah, no. Well, it depends. I guess it's difficult to give very general rules about that, right? It depends on the specific research question and the thing that you want to measure. I know that's a bit of a lame answer, but I think it's the best answer I can give.
Yeah.
So
No, if I imagine, for instance, like by coincidence, like half of the participants in the control condition has faster computers and half the participants in the experimental condition, then everything is ruined.
yeah, so it will add an additional source of noise in between subject experiment as in any other experiment. But of course, at the same time, it will also average out, right? If your sampling is big enough, but it will reduce statistical power in that context. But in many cases, I would say in many cases, it's okay, the addition, the temporal jitter that you get. And also I've seen in experiments that we've done ourselves where we sort of try to check the timing that it is generally speaking okay, that it is quite rare for the timing to be off by more than a few frames, say. As far as we can tell after the fact based on the timestamps. But I would say one context in which you really don't want to do it is if you want to present stimuli for a very short period of time. Say that you have a masked priming experiment, for example, where you present the word and you want the word to be shown for exactly 2 display frames and then masked by something else. Then the timing basically needs to be perfect on every trial because it is crucial that the prime is presented for exactly 33 milliseconds, right? Because if it is presented for longer, you will just see it and it will not really be a subliminal prime anymore, say. And if it is presented for shorter, then it will not be presented at all, right? For 0 frames, for example. And then I would say the temporal jitter, the uncertainty that the browser-based experiment gives you is probably unacceptable. In most other cases, it will just be another source of noise in the same way that basically differences between participants and random differences in reaction time from one trial to the next are also a source of noise. They're not fundamentally different.
Another issue that I think occurs often in an online experiment is that it's difficult to determine the resolution of your own experiment.
That's a good point.
Yeah, we don't know,
Yeah.
because the resolution doesn't always correspond to the actual size of the screen, laptop device, and so on.
So the resolution is in a sense no longer applicable, but it's good that you bring this up actually. Let me give you an example of what that means. So let's say I'm clicking on run in browser just to test it. Up, there we go. Now what you're looking at is a this is annoying that there is really. Okay. Now what you're looking at here, this black screen is sort of a virtual window of 1024 by 768 pixels, because that's what I specified as the resolution in OpenSesame. But how big is it really? Well, that depends. For example, right now it actually is that size. But if I, like most people, I zoom in, it will become bigger and it will, have a very different size. And also if I scale the window, you see that the thing will actually scale along with my window. You see, it becomes much smaller because it doesn't fit anymore. And all of those things together mean that you don't know the physical size of the stimuli on your participant's computer, and you also don't know the size in pixels. In principle,